The behavior of herbivores may appear to be little more than the idle wanderings of animals in search of food and a place to rest. Far from a mundane activity, foraging is a process that provides insights into an age-old dilemma faced by animals and people alike. How do creatures of habit survive in a world whose only habit is change? The demands animals face in finding food to eat and a place to live are similar to those people face in making a living. These demands arise because social and physical environments change constantly. Change requires that each component of the system continually adapt. By understanding the challenges herbivores face and how they cope, people can manage more efficiently and effectively.
We live in a landscape, in an ecosystem that evolved with grazing through eons. You know, how far back you want to go, we had woolly mammoths grazing around here at some point. We had vast herds of large ungulates, some places one day, some places another. We have rare plants in this region that are totally reliant upon heavy grazing. And so the facts are pretty straightforward here. We have a grazing ecology.
When European man first came to the Southwest, they kind of brought with them a biblical attitude that we needed to conquer this land and develop it into a garden. It was missing something, and that something was man. And now we found that the interactions between plants and animals and all the functions and form in the ecosystems are just vastly more complex than we'd ever imagined. And now we're backpedaling, trying to get the picture and understand these sort of things. The same can be said with animal behavior. We drive by an old dairy cow sitting there chewing her cud out in the field, and we think, boy, you know, what a simple life. And that's about as dumb as it can get. And now we're realizing that these animals are the blood kin of the great herds of Africa, and that the animals are very complex. Their interactions with one another, their interactions with predators, interactions with forage are extraordinarily complex. The cow's ability to select her diet based on the nutrient content of the forage, her needs at the time, are extraordinary. And a cow can do so much more than the humans to balance her diet. The cow has always been able to outdo the human beings. And to think of her as this poor, dumb creature is not very accurate anymore. Now we're appreciating, God, I mean, just how complex she is.
Whether they're confined or foraging on open ranges, herbivores traverse an ever-changing landscape. Unlike humans who acquire nutritious foods from familiar and predictable haunts, grocery stores, restaurants, and gardens, herbivores must sift through an ever-changing landscape. Nature constantly alters the quantity of energy, protein, and minerals in the foods herbivores require. Moreover, all plants produce toxins that serve as chemical defenses against herbivores. Individuals must maneuver through these challenges, recognizing nutritional deficiencies in themselves and in the plants they eat. Individuals who do will survive. Those who don't won't.
Kathy was saying, well, why starch? What's starch?
Fred Provenza is a range scientist and behavioral researcher who works in the College of Natural Resources at Utah State University. He and his colleagues have spent the past 30 years investigating why animals behave as they do and the implications for managing animals in confinement on pastures and rangelands.
There are several challenges that animals face in attempting to make a living. If you think about them and think about us, there's some analogies that one could draw. For instance, nutrients, obtaining the nutrients that they need to live each day. For us, we do that by going to the grocery store. For them, the landscape basically is their grocery store. And we know that the different items in that store, the different plant species, all vary in terms of their concentrations of nutrients. Even the different parts of plants vary in terms of concentrations of nutrients. So one of the questions is, can animals select diets to balance for their nutritional needs? And if so, how can they do that? Toxins present another challenge to animals. You may not realize this, but virtually all plants contain toxins. We know that there are literally tens of thousands of different kinds of toxins, and broad classes of those. For instance, alkaloids. There's maybe 10,000 alkaloids that people have identified to date. And compounds like terpenoids, another 25,000, and so forth. And all these compounds vary in their structure and in their effect on the animal. Why are all these compounds there? Research of the past 20, 30 years has shown that these are defenses. They protect the plant against too much herbivory. In the case of garden vegetables and pasture plants, what we've done is to select for plants with low concentrations of these compounds, so they're not highly defended. Animals, including humans, can utilize large amounts of them. The downside of that is simply that now all other kind of creatures, insect pests, can utilize them too, and so what we have to do is start using pesticides where historically the defense compounds were the pesticides. And so the question is, given all the toxins in the environment, again, can animals detect toxins in plants, and if so, how can they do that? The other thing that relates is that the environment where a plant's growing influences the concentrations of nutrients and toxins. For instance, a plant growing in a fertile site is going to be different from an infertile site. From a wet site or in a moisture, different from a dry site or a dry year. Seasonally, plants vary also, though. We know that concentrations of nutrients and toxins change across seasons. Even within the day, concentrations of compounds are varying. The amount of sugars that are in plants are higher in the afternoon than they are in the morning, and same sort of things are happening with toxins. So again, it's a moving target that the animals are having. It's as though we were in a grocery store and you never know what the concentration of compounds in the lettuce or tomatoes or potatoes is going to be from one day to the next. That's the kind of challenge that they face. There are a couple other challenges probably be worth mentioning. One is simply the structure of plants and how plants are built, morphology of plants, spines and thorns and leaves, and simply the structure presents a challenge to animals as well. And one of the big challenges when it comes to grazing management is to maintain plant structure in a way where you maximize nutrient intake of animals. For instance, a lot of the work on management-intensive grazing is directed toward keeping plants in the vegetative state, which helps to maximize nutrient intake. Probably the last challenge, and one of the biggest ones, is simply moving animals to unfamiliar environments. In wildlife populations, that can happen as a result of natural disturbances, fire and flood, or forced immigration. As young animals grow up and have to move out, they're forced into unfamiliar environments, and that's a huge challenge for animals. Huge amount of mortality occurs during that time. We do that with domesticated animals. We move them from one place to the next, and not really realizing the tremendous challenge that is for animals. In New York, for instance, the challenge is trying to help animals to adapt to being in a pasture situation when they've been born and raised in confinement.
When people start this, they really have a lot of concern on whether or not it's going to work. I mean, in a lot of cases, the farms we've worked with have started out in a very poor economic condition. They've tried all the traditional stuff. They've had the cow in the barn. They've done the best job they know how, but the cost of the machinery and the fuel and the labor really is very, very high. In milk production, the price of milk that they're paid for the milk has not kept up with that rising cost syndrome. And as a result, when they go on pasture, they're in a situation where if we really make a mess of their farm, they're going to lose the farm. And when they do that, when they have that in the back of their mind as a thought, they're very cautious about what they do. So trying to get them to accept the idea and go for it full speed ahead it's a challenge every time we do that.
If you want to change your level of production or your way of managing the system, and you're at this point here, you're going to have to go down through this adaptation trough or this learning trough before you're ever going to come out up above in another way of performance. How long that takes may vary anywhere from a few weeks to as many as 3 years. There are many examples of people we've worked with in the past. Ray Bannister, for instance, in Montana, Bob Budd in Wyoming, Ray trying to change dietary habits of his herd, Bob trying to change habitat selection patterns. Why, it was 3 years for those animals to go through that trough and to make that transition. Both people were able to really increase the health of those systems, the plants, the soils, the water, the productivity of the animals even, and the number of animals that were on those places. But to do that, it had to take initial decreases in performance. In the end, though, the animals, the system, the humans, all were better as a result of that. But it's not for sissies to go through that trough.
Ray Bannister, a cattle producer from eastern Montana, is using behavioral principles as the basis of what he calls boom-bust management. With boom-bust, Ray confines his cattle in an area until they clean their platter, eating all the plants, not just the tasty ones. In the process, the cattle learn to satisfy their nutritional needs from a wider variety of plants, and Ray's rangelands are more uniformly grazed.
We want robust systems where you know disturbance is going to come, you know you're going to get hit, you know you're going to have continental glaciers, you know you're going to have volcanoes, you know you're going to have droughts, you know you're going to have grasshoppers, but you want a system tough that can take this hit and keep on going. And we want tough people, we want tough cattle, and we want tough land. And our whole goal is to build this robustness. And one of the key factors of building this robustness is boom-bust, because you teach the system how to recover. By dropping it way down and bringing it way up, the system becomes information rich. In range, that's a lot of variety, a lot of healthy roots, a lot of seed, and we want every piece of nutrient, we want every water competed pretty heavily for it. So when one species crashes, there's always another species that grabs that place and keeps the ground well covered. Before we started in this long rest, the weaning weights would run around about 500 pounds. When we started in this long rest, we dropped down to 350 pounds, and then the weaning weights kept cranking up. When I sold my calves, they were 511 pounds with no cutbacks on the steers. The cow gradually adapts to the diet that we expect her to eat. As you increase your production on the cow, you lower their ability to adapt because their nutrient requirement is too high. So you have to, when you start forcing stuff on cows, you better make sure they can take it or supplement them. But in times of hardship and stuff like that, it's real expensive to try to supplement them. So you can get yourself in trouble real quick. And that's why when you start into a different way of doing it, you should start very small, like maybe rest one little pasture in a corner of your place and just do it with that, and you'll start finding out the problems involved with this type of management. There's no universal solution to anything. You just have to start small and just start, if you can adapt to it, see if you can adapt to it, see if your cows can adapt to it. But always start small, don't go into anything big.
Adapting to an ever-changing world requires that animals and people alike try new things and learn from their mistakes. As Ray Bannister suggests, based on his experiences with boom-bust in Montana, it's best to start small, learn along the way, and stay flexible. Mark Kennedy makes the same points for people learning management-intensive grazing practices in Missouri.
In our management-intensive grazing schools here in Missouri, one of the things that we do try to teach, we have a segment called The Art and Science of Grazing Management. As I do some of the wrap-up sessions, I tell the producers, I think we can do a pretty good job teaching the science. We cannot teach the art. If it was pure science, with the technology that's available today with computers, the GIS, you could plug all this into a computer program, have the cows out in the field, you're setting up in the house, plug in a rotation schedule, go off on vacation, and the computer with the GIS and whatnot would actually force the cows to move on a scheduled basis. But that's if you're working off straight science. Our calculations really are based on averages. The math's pure, but it's based on maybe that one day out of the year when we're working with the average. It would be right one day. We're working with a dynamic living system. That's why we've got to build flexibility into these systems. We don't want to see producers get so rigid a system that they've definitely got a certain grazing period and a certain rest period. That needs to change throughout the year. In this part of the world, the way our conditions change almost daily, the speed of grass growth, cattle nutritional needs, nutritional quality of the pastures, so many different things are changing. You're going to make some mistakes along, but we try to turn those mistakes into learning experiences. And by that I mean if we're keeping a good job, doing a good job keeping some records, what we did and then what the reaction was, then maybe we won't make that same mistake again. Or if our production's not quite as good as what we had goaled, we can look back and determine why and know that wasn't the right thing to do. But there's so many people, they get hung up afraid they're going to make a mistake, they're afraid to start. And we tell them, go ahead and start, make your mistakes, turn them into learning experiences, and you'll be more successful that way. But you've got to get started sometime.
The key to survival for herbivores and for people who manage them is to constantly investigate new possibilities and adapt. To do so, animals and people alike must explore the unknown, make mistakes, and learn quickly from the errors that occur inevitably as part of the process of discovery. In the next 5 segments, we explore how animals and people adapt to ever-changing environments, the challenges and opportunities change presents, and the dilemmas along the way.